Hey, Elia, how you doing?
Very good. How's it going?
Very good. All right, welcome everyone. We'll just give everyone a few seconds to get warmed up, but while we're waiting up for everyone, we'll do some introductions, and I'm so excited for this session today. It's only going to be a quick 30 minutes, so we're going to have it packed full of information around Couchbase, around Tondo, around AI, and how you can apply some really amazing learnings into your own infrastructure and learn from just the coolest technology out there from the cloud to IoT and the edge. So, really quick, I'm Steph Rogers. I'm brand new to Couchbase. So, this is actually my first webcast with Couchbase. Really excited to join you all. I'm head of developer engagement here at Couchbase, leading a rock and roll team. What is Couchbase? Couchbase is a multi-model database that supports capabilities including key value, SQL++, full text search, analytics, eventing, cross-data center replication, and so much more. Even just newly announcing our vector search capabilities and features. So very excited to be talking about AI and the cool stuff happening over at Tondo with my friend Eliev here. Eliev, would love for you to give an introduction and talk a little bit about what you have going on at Tondo and your cool AI stuff.
Well, first of all, it's great to be here. I'm super excited for this session. Just a bit of background about myself. So I come from a physics, electronic engineering background. I was in the IT services industry for some years, then in several startups. I also served the Linux Foundation on some committees, and today I'm the CTO of Tondo Smart, which is a smart city IoT startup company, and I'll tell you all about Tondo later.
Awesome. So we'll dive right on in. If I know you have some really cool slides to share. You have a demo that you're going to show real time application of Couchbase, the infrastructure, and how you power the amazing technology that you have with smart streets, smart cities, smart roads. So we'll go ahead and dive right on in because this could be a packed session. So whenever you're ready to present, go on and jump in. While Eliav is getting ready with the slides, go ahead and, as Susan just put in the chat, let us know where you're joining in from. So I'm joining in actually from London, UK. Eliav, where are you joining in from?
I'm based in Tel Aviv, in Israel.
Very, very cool. So please go ahead and throw in the chat where you're coming in from as we get started. So tell us about Tondo, Eliav.
Yeah, so a bit about Tondo. So Tondo is a smart city company. We make infrastructure smart by making the lighting poles smart and then using the lighting poles as infrastructure for smart city applications. As I said, Tondo is a startup company. We are 35 people. We are based in Tel Aviv, Israel, and we have also a subsidiary in the US. So we work also in the United States, in Canada. We are using AI to actually provide value to customers. So we are a data platform. I'm going to tell you a bit about what we do. Several things that are important to say about Tondo is we are rapidly growing. We have today over 40 cities that we are managing in terms of smart lighting and smart infrastructure. And we also have one of the largest smart road projects in the world. And I'll show some of the things we do with data and smart lighting control. Just to explain what we do, I think I need to explain how we work with cities or how we work with these kinds of customers. So the idea is that the streetlights you have all over the place. These streetlights usually have older light bulbs, and municipalities and these kinds of organizations are replacing it to LED lights. And during the LED light replacement, they are getting a lot of benefits of energy saving and other things. And these LED lighting controls, these LED lights need controls. They need a controller that would sit on top of the light bulb. I want to show you how such a controller looks like. So this is the Tondo controller that we're installing on lighting poles. This controller has a cellular modem. It has also a Bluetooth chip on it, so it can communicate both to the cloud and to other things on the ground. And we use these smart lighting controllers to actually provide a lot of value, the energy saving, but also operational efficiency. And last but not least, we are allowing the pole to be electrified 24/7. And
And Elliot, to pause on that really quick, that's really cool, because what you're basically covering is everyone's like wish list of, I want, brighter streets, but I also want like energy savings. I want to be saving the planet, so I want to be really smart about what time do things turn on and off based on the activity around that area. I know I really value like lighting in my area when I'm walking around at early mornings or late at night. So I really appreciate that, and the focus on how do we teach this technology to turn on at the right times in the day or at night, depending on the circumstances around that. But also to have like that green energy messaging and positioning, but truly to apply it is a whole nother story. So that's really cool when we think about you'll be able to really know your footprint in this world and to be able to report back on that, where it's like, how are we actually saving the world and saving the planet through LEDs, but having the data to back that up too, which is really amazing. And I'm excited to see how you're going to be applying that.
Yeah, so I think the cool story is what we do with it, because it's not only about the operational efficiency. It's also about the data and what we do with the data, and make the pole real smart. I think one aspect that is important to understand is that each one of these controllers has a relay. It can turn the light on and off. It can command the LED light, and then the pole itself can be electrified 24/7. So I can install other applications on the pole, cameras, EV charging, other applications on every pole, because it's live. It has electricity during the day. Okay, that's a very important aspect of the story. The way we work with our customers is we start with replacement of streetlights to LEDs or installing these controllers, but then we take the data that comes from these controllers and send it to the cloud, and we are getting insights for our customers that is actually based on this data that comes back to the cloud. And I think the third stage is actually deploying other applications. Okay, so it's like a three-step process. Okay, we start with the controllers, but then we go to other stuff that is that can be installed on the poles. Okay,
I mean, and that's a lot of data. That is a ton of data.
Yeah, it's a lot of data. And what happens is that here we can see some details of how, let's say, more technical details or technical diagram of how such a solution looks like. Okay, you have the controller. The controller is on the pole. It's both cellular and it has also Bluetooth. This Bluetooth connectivity can provide connectivity to different sensors. We are doing things like power meter readers and water meter readers and other type flood sensors, other types of sensors. And we have this Bluetooth network, which is a local mesh network, but we use the cellular network to send the data to the IoT cloud. Okay, this is where it becomes interesting. This is where AI becomes a very important part of it, because when data gets to the IoT cloud, we want to use that data to provide insights, to provide value to customers. Okay, so that's the idea with the way things are deployed. And what I would like to do is just dive a bit into the AI story and explain how the data that comes from these controllers, these sensors, is actually being used, okay, to provide value to customers. Okay, so what I wanted to explain first is how an AI architecture is built. Okay, how we are working in AI. I mean, there are different ways, but I think this is like the let's say the go-to architecture when you talk about IoT. Okay, we have controllers and sensors. These controllers and sensors produce a lot of data. I will later show in demo different types of data, but there is telemetry, there's video, there is other types of information that comes from these sensors. And this data actually is being sent to the cloud. Okay, and when it arrives to the cloud, you need to first of all normalize this data. You need to make sure that this data is normalized, and after this normalization process, you actually store this data in a data lake. And as you know, we are using Couchbase to do that. Okay, this data is actually augmented or is being let's say transformed, and data is being added from the city management system. Okay, so it's like a fusion of data that comes into a single place, and on top of this let's say data store that is being accumulated, we are running machine learning, we're running deep learning, we are using the different, let's say, data artifacts that are being collected to produce the AI models and to actually provide insights out of this data.
And Eliav, on that, like when you're kind of going through your decision making process of, which brands you use or which tools that you use to make sure that you can, really build a data lake of enriched data to be able to, augment the data, help teach the learning modules, power the background of the AI. What were some of the decision making choices that you were going through, and some of the testing and learning to help kind of choose the different tools that you use to make it all work?
Yeah, I think it's a great question. I think it's one of the aspects that actually led us to Couchbase, and I'll explain. Um, there are some things that are derived from the fact that you're using different types of controllers, different types of sensors. You have a very flexible data model. Each one of these sensors is sending a different collection of information. Okay, so you have temperature sensor sends temperature, but the controller sends energy information or other information. Okay, so we needed a lot of flexibility, and we understood that we needed a flexible data model, and this led us to a document database or JSON-based database kind of selection. And we wanted the developers to have the experience of a SQL-like language. Okay, we didn't want them to need to learn, like crazy query languages and these kinds of things. We wanted the SQL-like experience, and this comes from SQL++. And of course, the fact that we are using with IoT information, you get a lot of data. I mean, we are getting tens and hundreds of millions of data records every day. So we needed something that would be able to accommodate to the load and to the scalability of such a use case.
Absolutely. And I mean, when I think kind of on that first part where you were talking about basically ease of use, how do we go faster, but also like not have such a hard learning curve where it's like, let's find something that's easy to adopt for our developers to play with. Yeah. Get a creative on how do we power this very unique cloud to IoT AI. Yeah. That's awesome.
Yeah.
Thanks.
Yeah. So, and I want maybe to dive into why is big data needed. Okay. Just to give you some example of the scale needed or the scalability needed in such use cases. Okay, so when you think, let's think about one of our project. Okay, the Israeli Highway Authority project. We have 150,000 poles. Each pole sends a very small data packet every minute. Okay, but when you run the calculation, you understand that this database needs to be able to get 2,500 packets per second only from this simple keep alive transaction. Okay, I'm not talking about the rest of the data that has been accumulated in the system. So the data acquisition, the ability of the database to actually withstand the load of an IoT application is very important. And of course, when you add the AI queries and the different, let's say, processing predictions and different processing elements that work with this data, it becomes even 10 times or 100 times bigger. Okay, so you need an infrastructure that is capable of handling very, let's say, high load use cases when you work with IoT. Okay, so just gives you some feeling of what it means to work with with IoT or in the IoT scenario.
Wow. That is a ton of data to be able to create and put into the data lake and have it still be like scalable, clean, accurate, yeah, and secure.
So so let's say I want to get started and I want to build my data lake. So what do I need? Okay, so again, I won't dive into everything about AI because it's very, very, let's say, big. I mean, you have different types of models, different types of elements. Okay, but the idea with building machine learning or building these types of applications is actually understanding that machine learning neural networks usually are split into two types. Okay, you have the model building jobs or the train. I'll call it training. Okay, this is for for supervised training or unsupervised training, but you need jobs that build models, which means that they're taking examples from the data lake, they're building like the predictive models out of the information that you have in your data lake. And then there's like the immediate prediction part, which means that let's say I have I don't know, a street, and suddenly the street lights went off. Okay, I want to very quickly identify this pattern and make sure that I actually provide an alert quickly to the customer. Okay, so they can send somebody to actually fix the lights. Okay, so the idea is that we train the system according to the data that we have in our data lake, and the data lake I want to remind you that includes both the IoT data, but also external information that comes from the city. Okay, sometimes it's the height of the pole or the type of I don't know of LED light that was installed, or other information that comes from the city. And we have the IoT information, like the energy and the connectivity state and these kinds of telemetry. Okay, so the idea is to take this information to actually take this information to get together, build models, and then act or use prediction on these models in order to actually provide the value to the customer. Okay, so that's
Yes,
the
and it's
way.
amazing because yeah, with all those data points coming in, being able to pinpoint exactly when something is going wrong or what data entry point isn't quite accurate or when we need to flag something to a customer quickly, to be able to have such a vast data lake of billions and billions of billions of points coming in, but to be able to pinpoint and to be able to start predicting and be able to provide that report back with such a clean infrastructure is it's huge for this type of project.
Yeah, and it's very important for this kind of project. And I want also to explain something about the infrastructure, which again led us to Couchbase, and I want to explain why. Okay, when you have such a system, some of the customers need the ability, first of all, to install it in their private clouds. Some of the customers want it in a public cloud. Sometimes you need to install it even on premise. Okay, and we need something that is scalable enough, or we need a system that is scalable enough to be able to actually run anywhere and give our DevOps team the ability to actually work with it seamlessly and have, let's say, a relatively simple experience working with the product. Okay, and we developed our entire system to run on Kubernetes. Okay, so which means that we can deploy it, in Azure and on AWS. Doesn't matter. We can deploy it anywhere. And we have started with the community edition, with the Couchbase community edition. We had great experience with the community edition. Then we wanted to scale out and to make sure that we can actually manage a 24/7 infrastructure on Kubernetes. And we shifted to the enterprise edition because we have the operator, we have the different tools that enable us to actually have better scalability and better maintenance workflows when working with Couchbase. So overall, the moment you run on Kubernetes, you can actually deploy it very quickly. You can scale out very quickly. You can upgrade servers very quickly. So the idea is to give you the flexibility and also the scalability to work in such an infrastructure.
Very cool. Very cool. I know we have a lot of folks fans of that on this call on the recording.
So having talked about AI, I just want to give some examples of how we actually provide value using AI. Okay, so you see on the left-hand side, one of the examples is auto tagging. I'm an installer. Okay, I come to the pole, I put the controller on the pole, I activate the electricity, and now what you do in, let's say, traditional systems, usually you take the installer through a very tiresome list of screens to type in information about the controller. Okay, one of the things we are doing, we are actually auto tagging the controllers. We are learning where it is installed. We are giving the installer an experience of scanning the controller with a mobile app, and practically that's it. The controller learns the driver, the LED, its location. It auto tags its location, and it provides a very, very simple installation experience. Okay, so this is one way we use AI. The second example you see here is electrical theft. Because we have uh, energy reading from all our controllers, we have it also in the cabinet, which is the electricity cabinet controller. We actually learn the patterns of how electricity is being used, and we provide alerts when we discover something is out of pattern. Okay, so we actually have pattern recognition algorithms that run on the big data. We learn the behavior, the past behavior of the cabinet, and if we see the cabinet is not behaving as expected, we turn on an alert for the customer. Listen, something's going wrong. And an interesting thing that we see in the field is that this is one of the greatest values of the system, because municipalities and highway authorities are discovering that people are actually using their electricity to power their own, I don't know, the garden or their own their own premises based on the electricity of the provider, and we can quickly discover these kinds of usages because we are running pattern recognition algorithms on the data. Okay.
Yeah.
You can see also on the right when a specific phase in a street is has a problem. Sometimes the patterns are not really easy to see. Okay, and we are using analytics to actually discover these kinds of problems or issues in the electrical infrastructure. Okay, so these are just examples of how we utilize AI in the world of lighting. So with that, what I wanted to do, I just wanted to show you the system in real life. I mean, how it looks. Okay, so
Absolutely. And I think something you highlighted, which was fantastic while we're transitioning over to the demo, is just the importance of performance and flexibility for AI-powered applications or adaptive applications in, because slow applications won't be able to report on this accurately at the speed that we need it to. So we need those to be flexible, and you need a multi-purpose database in order to power such knowledge and readings that are coming in at billions times per second. So it's really cool.
Yeah, it's really cool, and and I want to show you how AI looks in real life. Okay, so I just dived into one of our customers' dashboards. Okay, this is one of the regions of smart lighting, smart road application actually, and we see this region has 66,000 poles, okay, or controllers on poles, and I can dive into a specific road. Okay, I'm just diving into a specific highway. This is a highway, okay, and each one of these circles you see here is actually a live controller. Okay, it sends data live. It has a cellular modem on it. Okay, so this controller has a SIM card. This modem is being used to send information to the cloud, and I can dive into a specific controller. I currently actually dived into a specific light pole. Okay, of course I can control the pole, and this pole actually sends information to the cloud. Okay, you can see the current temperature on the controller, and it's live. Okay, so the idea is that the entire system is live all the time. These poles are electrified 24/7. That's why I can install other IoT applications on these poles. Okay, I can do more things using the electricity I have on these poles. Okay, but the idea is each one of these poles is electrified. It has a schedule. I can look at the schedule of this specific pole. This pole actually, the system uses the relocation of the pole to actually decide when to turn the light on and turn the light off. Okay, so it doesn't use a photo sensor. It actually uses information from the cloud. Okay, so each one of these controllers actually sends data to the backend of the system. Except from the pole itself, we also have another element in our solution, which is the cabinets. Okay, we have a controller in the cabinet. Just dived into the cabinet. You can see that the poles are automatically tagged, the circuits. You see the circuit numbers 3, 4, 1, 2. So the system is actually accumulating a lot of information about these poles. And this cabinet controller actually sends information like its current energy consumption or monitoring of the electricity quality. We can see the current harmonics on the electricity live on this cabinet, okay? And it's all driven from the big data database that sits on the back of the system, okay? So it's all based on data. Each one of these elements in the system actually has this, I call it big data backend that is being used to accumulate the data. And I can show you a cool thing here, which is this highway has a parking lot nearby. Okay, you see this parking lot? So there's a sensor also that is connected to the system. So when a car gets in at night, the dimming gets up to 100% for 20 minutes and then goes back down to 20%. This is how we conserve the environment. This is a nature reserve, so we actually keep the animals safe. So this is just an example, a simple example of smart lighting use case, okay, that we use the ability to interact with these devices in order to provide the value. What I wanted to show you is the alert system. Okay, we have this alert system that is at the back of the system. The big data infrastructure actually monitors the different elements that we have and discovers failures in the system. Okay, so we can see that there is a specific electrical fault that is out of pattern, or we have electricity theft. All these types of use cases are being monitored by the AI in the system. Okay, so the idea is that we open tickets for the customer when we have a failure in a specific portion of the road. And this is how the authority is actually benefiting from AI and from the performance of such a system in order to provide better value to customers. So I'll stop here with the demo.
No, that was great. That was perfect timing too. And Eliav, while we have a few minutes left, I have a few questions. We'll get started. And if anyone has any questions from the group, I'll go ahead and say those out loud for us. So Eliav, in your time of running these massive complex projects from cloud to IoT for your customers, tell us about some of the interesting experiences, like educating customers on the value of AI and having a multi-model database and just the benefits to them when it comes to having a smart city powered by AI and the cost effectiveness for that.
Yes, I think it's true to not only for AI, but it's true for every system. You need to first of all understand the customer and understand the customer's needs. So I think AI for the sake of AI is not really interesting. You first of all need to understand what value you can bring from this type of information, or what are the needs of the customer. I think this is the first thing. The second thing is making sure you have the right infrastructure. I mean, I've seen again, I don't want to talk about competitors, but I've seen other players in the market that they're using like very traditional SQL-based databases and try to provide the same value. And I think that you need to understand that when you work in these kinds of use cases, the data grows exponentially. I mean, you start with very simple electricity telemetry, but then it grows very quickly, and you get data from the city, and you get data from other sources, and you have to have you have to plan to have the right infrastructure in terms of your databases, in terms of the way you model the information. You have to have flexible infrastructure. I spoke a bit about Kubernetes and its value to us. You need also to make sure that from the deployment perspective and the infrastructure perspective, you are covered with a solution that can really provide your developers the experience they need in order to actually focus on the use case and not focus on different, let's say, technical issues that they have working with the current data solution. So I think we invested a lot of energy making sure we have an IoT platform that is flexible enough to cover these kinds of use cases, and also to make sure that we have the right tool in terms of data model to accommodate to all the types of IoT use cases. Maybe when I think of my experience working with these kind of use cases, I see today requirements coming from customers that I didn't even think about when we started the project. And I think that's the
Yeah,
really nice thing about working with a JSON-based database. The fact that you can add new data fields, you can add new data artifacts very quickly, and still have the same infrastructure.
absolutely. And especially as we continue to think about where the future is going and how AI and vector search and AI powered adaptive applications and all the things that we still don't even know we can do yet. It's really exciting to see something like what you're doing applied from cloud to IoT with hardware, with all the cool data points and massive data lakes to be able to provide a lot of value. So yeah, the growth potential is amazing when you think about productivity, scalability, just saving time to focus on the stuff that really matters and is very innovative and the next generation of how we do this. Well, thank you so much, Eliav. If anyone has any questions, feel free to reach out on our Twitter. Feel free to reach out on our Discord channels. We're going to be sending out a bit of a documentation set that has everything you need to know, from some really cool case studies about Tondo that we've done recently, how to connect with us on Discord, and all the different ways that we can help you out. So sending over some really relevant content your way. Thank you so much, Elia, for coming on the webcast, and we look forward to having more conversations with you as this continues to grow. Appreciate it.
Thank you. It's been awesome. Thank you.
All
See
right.
you guys.
Thank you.